Hello, this video is on solving radical equations. This one's going to be pretty short. The concept is pretty easy and there are not too many little wrinkles to worry about. There's just one really. Okay, so a radical equation is basically an equation that has the variable that you're solving for inside the radical. Simple example would be this is an example of a radical equation. The solution is obviously 1. We're going to definitely see more complicated radical equations. So don't forget this foundational fact that we've been using this entire unit, which is rad of something times rad of the same thing equals that thing. And I'm going to rewrite it like this. I haven't written it like that in the past, but I'm writing it like this for a reason, and you'll see that in a second. So when you solve a radical equation, you approach each equation the same way. There's basically 3 phases of the solving process. The first phase is you isolate the radical. So just get the radical by itself on the left or right. And once you do that, you square both sides of the equation. And I'm going to put in parentheses here, usually. You square both sides of the equation, and you'll see what I mean in a minute. And then after you square both sides, you just continue to solve as you would normally, because after you square both sides, there's no more rad to worry about, so then the equation will look like a more normal equation that you're used to. Okay, we'll start with a pretty simple example. 2 plus rad x minus 5 equals 3. So first phase, isolate the rad. There we go. Second phase, square both sides. And now the rad is gone, solve as normal. And then here's a habit you really need to get into when solving radical equations, and that is checking your answer. So I'm going to plug 6 back in to the original equation. Okay, so it checks out. Okay, second example. Now we have 3x in the rad. That minus x is not in the rad. First phase, isolate the rad. Rad is now isolated, so now we square both sides. Now I'm actually going to write parentheses and the exponent this time so that we don't make any mistakes. And on the right side, since this is a binomial, we have to be careful when we're squaring. Okay, no more rad. We have a degree 2 equation. We have a quadratic. So in this situation, we don't get all the x's on one side. and all the terms without x's on the other side, we get everything to one side and make the other side 0. Okay, I hope that this is factorable, and playing the game, I do get winners, -12 and -3, and after the factoring process, I get x minus 3, x minus 12. So that gives me two solutions for x equals 3 or 12. Okay, now before I conclude there are two answers, I should check. So if I put 3 in, I get square root of 9 minus 3 equals -6. So that one doesn't work. And then if I put in 12, we're at 36 minus 12 equals -6. 6 minus 12 equals -6. -6 equals -6. That one does work. So after checking, I see that 3 is not a valid solution and 12 is. So it ends up being just one solution for x. And this is what I meant when I said it's important to check. Because the solutions sometimes work, as in this case, but one of the two didn't work in the second example. There's a special name for that. So 3 is an extraneous solution, which means that it comes out as a solution somewhere in the process, but then when you check in the original equation, it isn't. So it's faking you out, trying to convince you that it is a solution, but it isn't. That's an extraneous solution. Okay, I have one more example for you. Okay, notice the difference in this equation. Cube root of 2 minus x, not square root. So squaring both sides will not accomplish getting rid of that radical. We must instead cube both sides. And I'll put in parentheses cubed both sides. Okay, and then I end up with x equals -6, and I'll do the check over here. And it works. Okay, so don't forget, when you see an index there that is other than square root, make sure you raise both sides to the correct exponent. Okay, that's all for this time. Bye-bye.